All right. Hello, everyone. Welcome to the wasmCloud community meeting for Wednesday, May the 10th. Let me go ahead and share the agenda. So we're going to be talking about a couple of things today, starting first with a demo and a showcase about what Roman has been working so diligently on in the OTP host repo, which is basically transforming the way that we do releases into using an open source project called Burrito. Very delicious name. The Beam Burrito is what they call it, but it's a self-extracting, essentially, tarball for an Elixir release. And that's going to make our distribution and platform support a lot more varied across the operating systems and architectures that we support. Roman, of course, is going to talk more about that. We're going to discuss something that came up in our community Slack a little earlier this week around more built-in capability providers, and built-in air quotes because they won't be built-ins, but they'll be like included. Anyways, more on that here in a couple of minutes. And then Bailey is going to talk about wasmCloud and its path to becoming a CNCF incubating project, which is really exciting. So without further ado, why don't we go ahead and get started? Roman, take it away on talking about Beam Burritos.
Do you hear me now? All right, cool. Sorry, let me just share my screen.
I can only see the top of your head, though.
I only see it from the eyes up, so it's like you're doing one of these like peekaboo. It's like you're looking over a fence.
Yeah, not sure what to do about that. That could be some interesting Zoom thing. Let me try to turn it off and on. Let's hope up.
Although, if you wanted to change your username to Peekaboo Roman, I think that's another acceptable solution here.
Okay, do you hear me right now? Do you see me okay? Or yeah, that's good. All right, and my screen also is visible, or yeah, okay, yep. Cool.
Yeah.
All right. So Burrito. So something that we have encountered, noticed is that sometimes it could be a bit difficult for people to start up wasmCloud OTP because of different dependencies, mostly brought into due to the fact that we use Erlang and Elixir to actually distribute wasmCloud. So something that both me and Patrick have worked over the last few weeks is to making that all onboarding kind of simpler, such that wasmCloud OTP host would just work in various different contexts, different systems with as little amount of dependencies as possible. And so maybe a quick kind of intro of how this whole process actually works today with normal Elixir projects is that basically application developers, they call mixed release, and then the whole Erlang distribution, which is currently running on the system, is getting bundled basically together in one directory. And essentially that is what is then shipped to customers or to users of that application. So what we switched to is a project called Burrito, which expands a little bit on this approach, where instead of bundling the exact Erlang distribution of the system on which the release is being made, you can now specify which Erlang distribution you actually want to package, and then Burrito essentially creates one simple executable, which is then built specifically for the system which you're packaging, and it then self-extracts. So let's start with the example. This would be a more interesting thing. So unfortunately, we had some issues with GitHub Actions today. So it's an older build, but these artifacts are just as good as the fresh ones going to be built. So I'm going to just fetch one of these artifacts. I'm going to try to run it in a Docker container and kind of show how it works. So I have already done it before, and I have fetched one of these zip files over here, and I just unpacked it. So let's try to run Ubuntu container, Ubuntu 2004. I'm going to map the port 4000 for the washboard. inside a container to my host system. And I'm going to just mount all my file system to the container. So the only dependency on Ubuntu today we have is CH certificates. In most cases, this should be already installed on the system, so it's not something that normal users would need to install. But of course, in a new Docker container, they're not there yet, so I would have to install these. So going to do apt update, then apt install CH certificates. And this is just to be able to establish TLS connections, essentially. So I've also fetched the latest NAT server. It's just a recent release package for Linux. And I'm going to start NAT in the background. Now I'm going to start GNU build a wasmCloud host. And so what this is going to do right now is using Burrito, which actually uses Zig under the hood to cross-compile these things. So it's a single binary which is going to self-extract itself into a directory on my inside my Docker container. And now I can go to localhost 4000, and in a moment I should see my washboard. Here it is. Right. So as you've seen, I just took a completely new Docker container with Ubuntu 20.04 running, and I just installed CH certificates. And that's it, right? So I have my wasmCloud host running, and now I can actually kill it. I can run again the same binary, and this time it's not going to actually extract itself anymore. It's already is extracted on the system, so it's going to just run it directly. And yeah, I don't need to care about any. I don't need to even know about the fact that we're actually using Erlang under the hood. It's just a single binary which is then self-extracting and it can be run. In fact, I can do the same on Alpine. And I'll have to, of course, close this one because I already allocated the port 4000. So on Alpine, although I do have to note that our providers currently do not support Alpine, but I guess that's something that we could work in the future. So on Alpine, I can do something similar. On Alpine, I already have the certificates, and on Alpine, the only dependency we have is actually libgcc, and that's something that is brought in by Rust compiler, in fact. So hopefully it's going to go away soon. So here we go. We again to start NAT, and we're going to start in this case, wasmCloud host for Muscle, because Alpine uses a different libc toolchain called Muscle. So again, it's going to self-extract itself in the system, and in a moment it should start. So it's extracted itself. Now I should be able to again go to host 4000, and sure enough, I again see my washboard just as I did before. Right, so it works on both of these systems, and there's actually only one dependency which we actually were necessary. Yeah, so this also supports Windows and Mac, and on those systems, in fact, there are no dependencies, so this should just work out of the box. Yeah, if you're curious how it works, I definitely encourage you to check out the Burrito project. And yeah, as I said, they use Zig to actually build these self-extracting binaries, and it's cross-compiled for different targets. And so one thing here to mention also in terms of like how we actually do it in our wasmCloud OTP repository is that this PR that I was talking about, which we are hoping to get merged, is that we actually build Linux distribution fully reproducibly. So it's something that it gives you exactly the same binary if you were to run it locally or in CI, and we use Nix for that. It's a project which I encourage you to take a look at if you want to. But essentially, it's just a build tool to build stuff reproducibly, right? We also use Nix actually to build binaries for Windows and Mac, but before we actually can do that, we first have to build the Rust sniffs outside this whole sandbox. If you're curious to learn more, I'm happy to share the details, but I guess it's out of scope for this particular call. Guess if anyone has any questions.
Thanks, Roman. I thought I might summarize like the why people should be excited about this. If you've been in our Slack for a while, you've probably seen people complain about when they first get started with wasmCloud, they've got to install OpenSSL, and it's different on different, if you're on Linux, Ubuntu 22 versus latest and greatest, that kind of thing. That's like the first thing people run into. And this gives us a single binary with that included. So you get one thing that you install, and it's kind of like your batteries included wasmCloud host.
Yeah, so in fact, we compile our own Erlang to actually get this, get here, right? And we statically link everything we can, but of course, there are some things we cannot statically link just because it's Erlang. And actually, one thing I didn't mention here, I probably should have, is that so now these binaries also work without any dependencies on the GitHub Action runners. So you don't actually need to install anything on the runners if you were to use GitHub Actions. Let's say you wanted to test this, test what's about OTP. If you want an actor and start OTP and test that in CI, well, you don't need to do anything. You can just run the binary.
Oh yeah, that makes sense. That's like a perfect way to prove the point of the whole thing. You don't have to install any extra dependencies to start testing out with wasmCloud. That's really great.
And forgive me if I'm wrong, Roman, but it actually looked like this release only took like 24 minutes. That's a little quicker than our Docker cross compile that we used to do, huh?
Yeah, so there's no Docker actually used for a release. So everything is either built natively or natively or cross-compiled for another system. And so one thing we get with NIX and reproducibility, which I mentioned, is actually caching. So you can see here, there's a difference here in these two builds, right? So one took 20 minutes, another one took 3 minutes, and you ask why. Okay, these took like very similar things, right? And so what happened here is that I made a change, which actually changed the NIF. And so because the NIF changed, right, and NIF is a dependency of the whole, the binary, resulting binary, right? So I actually had to build NIF from scratch in this build. But in the other build, which took only 3 minutes, the NIF change wasn't actually required. Or in fact, I'm wrong. There was a different dependency. But the point is that the dependency was not actually used. It wasn't. It was NIF. It was different. So because we compiled NIF for ARM64, and there was NIF for x86. So when I made a change for ARM64, we had to recompile the NIF for ARM64 and update our cache, right? And then next pull that new thing from cache. But for x86, it was already cached, so it actually didn't need to build the NIF. And next guys before using the SNF built the burrito binary. So again, I just fetched that binary from the cache and built the NIF. So Barry asked a question about the NIF. So a NIF actually is Elixir. It's a dynamic library which we actually write in Rust to interface with things like wasmCloud under the hood. We use wasmCloud library that I've developed earlier. We presented that, and so NIF is the entry point for Elixir then to actually call these kind of Rust functions directly.
Nice. Well, Roman, thank you so much for showing that off. I wanted to just make one more call out that for you, the people, this isn't going to result in any real changes to your workflow. I'm going to try to push in this change, and it may just end up being a patch release. We'll probably do a minor, but we'll push up a new version of the OTP host, and then I'll get that integrated in Wash. So effectively, the next time that you download the latest and greatest Wash, with this change, we'll be executing this single self-extracting tarball instead of kind of the mix release directory structure. So, we're going to be changing kind of the format, but it's not going to change the way that you actually launch wasmCloud. You should just notice that as you start to work on different types of Linux targets, and maybe if you get a new MacBook and you haven't installed OpenSSL on it yet, you're going to notice that it just launches without you having to do that, which is super huge. These are some of the older issues that we've had running in OTP and in Wash for a little while, and we're really excited. I'm really excited to push this in. So thank you, Roman. Anybody have any other questions around kind of the whole Pareto release strategy? All right, awesome. Well, I think now we'll move on to the next agenda item that we have today. I'll just share it really briefly so that everybody can remember. We queued up a discussion for built-in capability providers to find at runtime. And I want to just do a little bit of disambiguating right before we start. So the wasmCloud host has a couple of built-ins, namely number gen and logging, that just kind of come as core capabilities of the host. It's not likely that you're going to want to use many different implementations of things where you just want to generate a random number. And often for things like logging, you want to have something built in that you don't have to link to an external provider. You just want it to work with the current host. And the host can provide a different implementation, but it's not the same pluggability as a normal capability provider. And this discussion isn't really around those. It's more around a nuance of thinking about teams of developers who are using wasmCloud will want to have a certain set of core capability providers that many different applications can access, and kind of having those available by default. It's not that we would change anything or build in more capability providers. It's just that if you were working on a project and everybody's using an HTTP server, then you'll probably want to have an HTTP server provider available. Now that can still be hot swapped and hot upgraded to a new version to resolve vulnerabilities, all the things. We're not changing any of the core value there. But really it's more around like when you run a wasmCloud host, should there be a way to kind of configure a set of capability providers to run that are treated like built-ins. So you don't have to explicitly link to them, configure the links and things like that. And of course, there's nuances to every part of that statement, but I wanted to set a little bit of background. And Jordan, I think you were the one who actually started this thread and started talking about this use case. Did you want to, would you mind elaborating a little bit more on what you were thinking about, especially if I mischaracterized it? I see you unmuted, Jordan, but I can't hear you. Uh-oh. Jordan responded in the Slack. What did you say, Liam? Sorry.
I said we could make this a game of charades. You know, Jordan, you come on. It could be like 2 words. Sounds like go runner.
Is this working?
It's working.
So when you work on a computer with one USB 2 device, you have to remember to plug your microphone back in. What was the question?
All right, I'm pulling up the recording, the live stream. We're going back 2 minutes and we'll replay it now. So Jordan, you kind of you brought up the question a little earlier in the week around kind of adding the core, like being able to configure a core set of capability providers that act like built-ins.
Yeah. So I mean, we actually started this discussion, I think 2 or 3 talks ago, right? It was all over. It was we're talking about crypto, right? They're like built-in number generators. And I'm like, the built-ins that we provide, they're really good for like prototyping and using locally. But when I think about wasmCloud deployed wherever, right? We don't want people to have to then remove logging and remove the built-in logging contract and then relink the use a different, what is it, contract ID to be, to use logging or something like, and I'm just using logging because that's the one I was specifically using at the time. But then it dawned on me, like, if we can start the host and these built-ins are like, in my imaginary world, there's an ops team that starts a cluster of wasmCloud hosts, and they start them with, if they start them with no like built-in modules, and then we use the logging built-in that's already there. We use the number gen that's already there. But if there's like in my mind, like a directory of WebAssembly modules that fit some certain schema, they get hot plugged into like built-in number gen, built-in logging, and they behave differently. That's kind of where my mind was at, because I don't want to rewrite all my actors and providers to use a different logging contract, which I guess it wouldn't, but I also don't want to rewrite my CI to use a different wasmCloud built-in logging, wasmCloud built-in number gen, because now it depends on what production level I'm at as to what contract I get, which doesn't feel smooth.
Okay, and so I know you're talking about logging. Do you see this kind of concept extending to other like
I think
capabilities
anyone that's done like large scale DevOps, right? You got like 50 applications running in this environment, and there's like a handful of things you need them all to do. We need them all to log the same way. We need them all to use, I don't know, the same clock. We need them all to do X number of things. Even this goes back to, is getting secrets a built-in or something along those lines, right? Are we all going to get secrets the same way? But then there's things the developer wants to do, like maybe I want to use this HTTP server because it behaves one way, or I want to use this HTTP server. Like the ops team shouldn't really care. There should just be approved HTTP servers. Kevin's on. Ooh, I'm about to get slapped down. Do it, Kevin.
Well, just because it's you, Jordan.
I accept that.
No, I guess so. For some historical context, a very long time ago, back when we all rode dinosaurs to our wasmCloud hosts, there was a specific need for differentiating between a built-in contract like wasmCloud built-in logging and then a non-built-in contract. And part of what we're doing like right now is taking a look at all of our contracts and seeing how they need to evolve in order to move forward with the component stuff. And we're looking at the WASI contracts, like Bailey just put a link to WASI logging. The really short version is that whether something is a built-in to the host or not should not be represented in the contract ID. So there should be one logging contract, and it should be up to the host whether it decides to satisfy with a built-in or with a provider somewhere else. A lot of this had to do with not wanting people to have to create link definitions between their actor and a logging provider. And so there are some design issues around that, but Jordan, I think your point is spot on in that if you find yourself in a position where you have to use a different contract ID between dev and prod, then that contract is wrong, and it's the wrong level of abstraction. You should have the same contract no matter where you're running, whether it's on your laptop or dev or prod or on the edge or in a Raspberry Pi. So we're aware of the impedance mismatch in the built-in contracts, and so we're going to, as we move forward, we're going to make sure that those kinds of things are corrected. So I can see a very near future where there is no such thing as a built-in contract. There's just a contract that may or may not be satisfied by built-in.
And do you foresee the built-in capabilities being pluggable or hard-coded into the host?
It depends entirely on the host, right? So what an OTP host can treat as a plugin and how it treats those plugins is probably different than what like a Rust host might be able to treat as plugins. So it's entirely up to the host implementation. So, for example, let's say you've got a JavaScript host, right? What the JavaScript host can do in terms of plugins is probably far more limited than some of the other stuff is. So the JavaScript might have more quote unquote hard-coded built-ins, but then, the OTP host, we might be able to allow people to write their built-in, or what I was referring to as auto start providers. You could write those in Elixir or Erlang and just have them loaded into the host that way. So there's a ton of possibilities, but your core point is definitely spot on, that we need to resolve that discrepancy in the contracts.
Very cool. And I guess my last question is, can we please make can we talk about maybe allowing the built-ins to somehow emit what they're doing on the lattice? It seems like they're the only ones that we have no visibility into. Like I played this week writing I wrote an actor that parses out logs. It was supposed to, and then I completely forgot that even when we're using the logging contract, it's writing them straight to like standard out and not echoing it onto the lattice anywhere.
Yeah, so that's actually another bigger question too, and one that hopefully we will solve for more than just built-ins. But yeah, there's a general need for providers to be able to emit their own events, and they don't really have a good way of doing that right now. There's some built-in, there's some helper functions depending on how you're writing the provider, but yeah, there needs to be a better way for providers to emit events, better bidirectional communication between the providers and the host, and not forcing the actors to know the difference between a built-in and a non-built-in.
I had a little bit of a wild tangent. So Vance, if you wanted to ask your question, go ahead. I think it's probably a good time, and then we can get on to mine.
I'm just trying to understand how swapping out a provider, I guess it's a general question, but maybe not, because the difference between the built-ins and the external capability providers, however you characterize those, is that there's no link definitions. So just sticking with the built-ins, then if you're going to keep the contract, but you change to a different provider implementation, does that work in real time? I suppose if it's an internal, it's up to the host to handle it, right?
Yeah, so some of this is going to vary depending on the host, but if we're looking at like the OTP host, you should be able to, if you can delete and then add a new link definition between an actor and a provider, and So right now, today, you can't do that with like the built-in contracts because they are specifically built in. You can't link to an external version of wasmCloud built-in logging. But once that discrepancy is resolved, then it should just be a matter of changing which provider is the implementation for your logging or whatever.
Well, I'm going to assume today that the built-ins don't use the lattice. Is that not right?
That is correct. They don't.
Right. Because the link definitions are really all about the lattice. So, well, then how does it work when you change from one provider to another? So if I want to migrate from one implementation of the HTTP provider to another implementation of the same contract, how do you accomplish that?
Delete the link definition and create a new one targeting the new version of the provider.
In that order?
Yes.
That's service disruptive then.
No. It can be service disruptive, but if you delete the link definition, there's a bunch of little details in there.
Okay, I may now have taken us a little off tangent.
There's some lower level distributed systems type stuff in there that you're right, if it could be service disruptive. And there are plans for making it easier to smoothly transition from one provider to another. But you know, the time it takes to delete one link and add another one is pretty small. But yes, at its heart, that is a disruptive operation.
I just would have assumed that you would add the link first before deleting, but anyway, I don't think we're talking about built-ins anymore, so it's fine.
If you add the second link if you attempt to add a second link to a different provider with a different public key, it'll reject it because that actor is already linked to an implementation of that same contract.
Right.
An actor can only be linked to one implementation of any given contract with any given link name at a time.
Yeah.
Yeah, I think along that line, and then I'll ask my wild question. I think we've essentially we've brainstormed a couple of different ways to do that upgrade. Like for actors, we have a live upgrade feature. I think essentially what we want to do is, either we would still be collecting messages like in the process inbox, and then switch over the link like by deleting and then putting again, and then deliver the messages to the new link. We brainstormed around, like Bailey, great idea to do like A/B type testing, or maybe like a smaller, like a canary style deployment. And there's a lot of different strategies, but that one will probably need to save for its own full discussion, because that's a great piece. So the question that I was going to ask is around linking an actor to a capability provider in the first place, right? And in my mind, this serves two main purposes. The first one is to tell the wasmCloud runtime, it's like, hey, this actor is going to talk to this capability provider, and that's allowed and it's okay. And then the second purpose is to provide optional configuration values, so you can add configuration on a link def. Around that first one, how much security are we getting at runtime by validating that a link exists? I know that we would have to do complex things to make an actor talk to a provider without a link. But if that was something that didn't exist, like if it was just automatic, does that compromise us on security there? I got Kevin to nod, so a little.
Yeah, so the scary edge case scenario for that is you've got an actor, and the actor is signed with the capability to let's say talk to a key value provider, right? there's no assume that there's no link, and then wasmCloud does some heuristics to find a suitable provider because it's claimed for that provider. If wasmCloud then attempts to find a suitable provider, there's a number of potential issues. The first one is that it doesn't know which providers need config and which ones don't. The next one is that if there is an imposter on the network, it's conceivable that wasmCloud would choose the imposter first as the potential target for that. So that particular scenario is the main reason why links between actors and providers has always been both explicit and secured, because you need to have permissions on the lattice to be able to add a link definition. The actor needs to be signed with the particular claim related to that link definition. And then both the source and target of that invocation need to trust each other in order to make that call. And if we just sort of arbitrarily pick potential provider targets, all sorts of really unexpected problems would happen at runtime that are, most of the problem would be with unpredictable behavior, and security would almost be like a secondary problem.
Okay. Yeah, that makes a lot of sense.
Yeah, what Bailey's talking about is you can use link names to get some of this stuff working, but if the link name is something that the actor needs to use, then it can't change at runtime, because the actor won't be able to say, use this link name now, but use a different one later. Like, you can sort of get away with changing link names for like a messaging actor that only receives messages, because it necessarily wouldn't care which link name was the one that delivered the message. But you can't do that with something like a key value provider or even like the HTTP client.
Yeah, it's really interesting that on actor receive operations, the link name can change, but when an actor is calling something, it has to keep the link name in mind. It makes sense, but it's just interesting.
Is that a limitation? Is that a limitation of NATS because it can only publish on a specific subject, but subscribe to a start subject, or is that a chosen path?
It's more a chosen path. I think NATS, like subscribing on a different subject, is a means to an end to get it to the right place. But it is intentional. So a classic example we used before is where we have a service that has essentially a NATS front end and a NATS back end. So it uses a specific set of topics and a different connection to talk to backend services than it does to receive invocations, so people can publish requests to a NATS API. And just for separation of concerns, kind of like how you don't have a database exposed publicly, we use the backend link to publish things to the backend and the front end link to publish things back to the client requester. So it was a long-winded way of saying that it's not a limitation of NATS, which is good, because that means something that we can do our own design on. So I want to make sure that I'll give it I want to make sure we can do a few more minutes on this topic because it's fun, and we leave enough time for the incubating discussion at the end. The thing that I was kind of getting at around do we need to link to a provider is I'm trying to brainstorm around ways to make linking feel a little more natural or super easy in the majority of cases, because until you get to a more complex application structure, most of the time things are just running on the default link anyways. And for a lot of our capability providers, they don't even run with a set of configuration. HTTP server needs to know what port to listen on. But things like HTTP client is just making outbound HTTP requests. Things like, depending on how you set up your capability provider, NATs and Redis and things could have a default connection, so they don't need any link values either. And I kind of want that to just work. Like, I just want them to be connected. And then as soon as I think about it, like, you can run for example, Redis capability provider and a KV Vault capability provider, same contract, same link name in the same lattice. And there's no way for us to pick which one an actor should talk to by default. Unless we were to enforce some rule around one contract ID link name pair for providers. And that feels a little artificially restrictive and difficult in a different way. So anyways, no concrete suggestions, but enough thoughts put out there that 2 people raised their hands, so maybe we'll get somewhere. Jordan?
Concrete suggestion: rename the project to Wild wasmCloud West. No, so on the same topic though, right? One of the biggest pain points is the compiling link names into actors, right? I've found myself, I have 4 or 5 different compilation or compiled actors with different link names in them. So if we're going to talk about this subject, I'd like to talk about that little pain point too. Because I know a while back I brought it to Kevin and he said he had ideas, but I don't think we ever talked about it since.
So yeah, I had a comment on the use case that Brooks just brought up. I was trying to talk about some of the negative scenarios that would happen if we had implicit links. And like I said, in addition to the security problem, the big one is what Brooks mentioned, where if you can have many different providers all sitting on the same contract ID, all in the same lattice, and you definitely don't want actors to accidentally choose the wrong one. So if you're trying to store data in Redis and it ends up being dumped into Vault, then all sorts of things are going to be a problem. So that's one of the other many reasons why the links are explicit and durable.
I think there's certainly still things to think about. I know we're always kind of thinking about ways to improve links and the way that we do that separation there. But I think that definitely settles it for me for now. So I don't really know if we got a concrete action item to take out of this. Had the discussion around having additional. It kind of started with additional built-in type capability providers. Kevin, would you mind doing a kind of a wrap up of where you see this sitting now, and if there's an issue to come out of this, or if it's Jordan, feel free to talk as well, but more around what we should take away from this discussion.
So what is it that you wanted? Which thing did you want the state wrapped up in?
Mostly, I just wanted to know if Jordan feels like his question that he brought up in Slack earlier was addressed, and if we have some ideas either to improve or just some things to think about.
Vance just asked a question that I essentially asked in Slack, right? If the washboard should have a section at the bottom that says these built-ins are up and running so you can use them. I like that. I feel like my question was answered. Kevin said it's in the works. Therefore, it's in the works.
We should have a follow-up on writing up some RFCs around this, because we've Kevin's written a couple that are out there right now that have gotten some really good conversation, and we need more. You know, I don't know that we know the right answer yet, but it does seem like everybody's got ideas.
Well, so if okay, on that point though, like if you have a JavaScript host that has more quote unquote hard coded, and then we get to a Rust host that has the ability to do WebAssembly modules as plugins, as built-ins, and then the Elixir host has Elixir plugins, and then we lattice them all together, and I say use a built-in, and I'm saying built-in because that's just what we're talking about right now. How's it going? Oh God, Kevin, that was fast. All yours.
So I think a compromise between your Wild West, or Justin's Wild West, and where we are now is, if the list of built-ins is variable and we don't have contracts that specifically indicate whether or not they're built in. So if you are using, so the logic would go something like this, and I'm just spitballing here, so don't hold me to it, but the idea would be you have a contract, let's call it WASI logging. If the host has a built-in for WASI logging and there is no link definition within sight of that host, then it will automatically provide you with built-in unconfigured access to that provider. But if there is a link definition floating around in a lattice for that particular contract, then that one would take precedence. So in other words, you'd be able to have hosts that provide reasonable default built-ins, but only if no link exists for that particular contract. So that way you'd be able to have a logging, I think, is probably the best example, where the host is going to provide a default implementation that just emits the standard out. But if you deploy a distributed logger capability provider into the lattice, and then define a link definition between your actor and the distributed logger, then the host built-in won't handle that request. The distributed one will, and that way we have reliable heuristics to figure out which capability provider is the target, and we won't arbitrarily choose random capability providers to satisfy a request. So link definitions would stay meaningful, explicit, and durable, but we would have kind of a hierarchy of defaults that allow hosts to provide a variable number of built-ins.
I super love that. That should totally be an RFC slash.
Yep, I'll write that up.
Thank you, Kevin. I love that you, well, I hope that you love writing RFCs, because it, you do, you kill them every time. You're so ready to write them.
Yeah, writing is my happy place, so it's good.
Awesome. I think that sounds great. I'm really excited to think about how that, like, we could extend the host runtime, especially as we get to using things like WASI HTTP. Like, we could provide more and more built-ins, and then of course people can always override that with their own. That sounds awesome.
Yeah, one of the things that I think of when I think about like the about reasonable defaults is the HTTP client. Right now, today, you have to deploy an actual capability provider in order to give your actors the ability to make HTTP client requests. But a host could easily provide a default built-in for an HTTP client, and that way you wouldn't have to supply a link definition for it, and it would just work. The only problem would be is if if you have multiple types of hosts on the network, and one type of host has a default for the HTTP client and the other one doesn't, then you could run into problems. But that's a rabbit hole we can jump into later.
Yeah, that sounds like a good maybe addition to the control interface or something. You could ask a host what its built-ins are, or auction off an actor to a host that it provides the right built-ins, something.
Yeah, the host already dumps a labels dictionary. We could probably either use the labels dictionary or, add something similar. Just make it part of the host inventory.
True. Awesome. Well,
Actually,
I look forward.
It's a funny historical fact is, you probably remember this, the original Rust host used to enumerate built-ins when you queried the inventory.
Back with the dinosaurs like before. Well, cool. Well, I apologize, Bailey. I got super excited and drawn up in that, but I'm really happy that we have that RFC coming out of it. I'm going to go ahead and throw it to you with our remaining time to talk about wasmCloud incubating.
Yeah, thanks, Brooks. It's this will be really quick because the steps to become incubating are actually pretty simple, and we basically hit all of them already. I just wanted to make a call out that this was happening on the community call. You've probably seen me put in a couple different issues for things that I'd like to have done, but actually all the issues that I've put in so far are stages for getting to graduated and not actually incubating. But the majority of the vetting process within the CNCF starts at the incubating stage and less at the sandbox stage. And so one of the things they ask you to do is take a look at the graduated aspects and just show that you're moving in that direction, so that you'd be a really great, hosted project that is graduated. So right now we are at the sandbox stage, and what I expect us to be at really soon being maybe in 2 months. 2 months is probably would be my best bet. We'll be at the incubating stage. Hard goal for me is I want to be there before KubeCon in May. So what that basically means, we already do a lot of this stuff. The call out is that I plan on getting us to have an adopters markdown file. And I would love it if anybody who is a direct adopter, especially, folks that are on this call, if they could, talk about how they've been using wasmCloud, that will really help me make this last statement here. It's for at least 3, but as many as I can get is my goal. I think showing how it's being used in a lot of different places will be important, because the TOC who we send this to are partners in hooking up all kinds of different services within CNCF. Any questions? Oh, I forgot. Actually, yeah, go ahead.
I was gonna. Hey, no, you go ahead, Bailey. I'll do my thing later.
I was gonna call out the thing that you set up, Brooks, which is if you go to our wasmCloud root and then you click the OpenSSF best practices, we are at 96% almost there, which is what we need for the graduated stage. And we actually just got another green check here, so we're moving along. Probably meet this one already. So yeah, just like so close. 3 things, and one of those, it looks like I think we're already good. So very soon we'll have this one as well. Go ahead, Brooks.
Yeah, all right. I had a little thing. So hey, Bailey, I'm a user, and oh no, my mic cut out at that exact time.
I can hear you.
Okay, cool.
It sounds better than before, Brooks.
What?
Brooks,
Okay,
I
great.
think technically your link def was just redefined and you drained your voice from one mic to the other. All right.
Anyways, I'm a wasmCloud user, and I would love to give you my feedback and talk about what I'm doing with it. Bailey, how can I best get in contact with you to let you know?
If you are comfortable with it, I would say post it in the wasmCloud Slack, because then you'll get a bunch of emojis from everybody, because everybody loves seeing usage, like real usage. If you're not into that, send me a direct message, and I will write this. I'll include it in the report that we send to the TOC. But yeah, like Taylor said, get that sweet hit of emoji. Woo! See, finished before we were supposed to be done.
Nice. All right, everyone. Well, if anybody has any questions, say it now. All right. Well, I'm gonna go ahead and stop the stream, and we're all welcome to hang out for a little bit. I may, and thank you everybody for